We are going to revolutionize the phacoemulsification training by the use of simple 3D printed models. Before we start, I want to tell you a story of our new short-term phaco trainee. On her first day, she read as many books as possible. But she was not happy with her surgery. She tried watching multiple YouTube videos, but still she was struggling. So one day she came to me for suggestions.
सर नहीं हो रहा है, बिल्कुल भी कुछ स्टेप्स नहीं हो रहा है, थर-थर हो रहा है सर।
नहीं हो जाएगा। आप थोड़ा सा वीडियो देखेंगे तो एक बार आप ओरिएंट करिए और अपना जो बेस वीडियो है उसको रिकॉर्ड करके उसको ओरिएंट करिए, मेरे को दिखाइए, मैं आपको बताता हूँ कैसे करना है, ठीक है?
सर प्लीज हेल्प मी।
Then after thinking about her problem, I came up with this idea of making a large-scale training model to make her understand the basic science behind the surgery. Initially I made few prototypes. Then decided to make 3D printed model. We used free CAD software for designing. And we have also uploaded all the designs online for everyone to use. The most important point is understanding is that they are larger scale model. So no need of any microscope. Individual pieces can be studied separately. And best part is you can hold it and feel the anatomy. We bring to you a novel model which allows trainees to understand the basic anatomy and physics behind cataract surgery. This has two major practical applications. One for novice surgeon to orient them to the surgery basics. And second is while auditing the video to understand one's mistakes and solutions to the same. So our model consists of a base plate or the posterior capsule on which the nucleus sits in. And above that the anterior capsule with pre-cut rhexis is assembled. With this model we will mainly discuss nucleus management, cortex wash and IOL implantation. First we need to see if the nucleus is free in bag and can be rotated easily. Next comes the fun part. Let's start with divide and conquer on the 3D printed model. First initial trench has to be made. One need to start from proximal end of the rhexis and go distally till the rhexis rim. I have added the phaco machine sound for better understanding. Here the energy is delivered in a continuous manner. One needs to make a boat-shaped trench. And you can see the movement of phaco probe. Once it has sufficient depth, then we can rotate the nucleus. And then proceed with second trench in the similar fashion. Then we need to separate all the quadrants. Here we need to make sure that we are in sufficient depth of the trench. Then we need to proceed further with quadrant removal. Here you need to follow few steps. First give some energy bursts to bury and build occlusion. Then pull the piece out and emulsify it at the iris plane. And we need to protect the endothelium and posterior capsule. In the similar fashion all the quadrants are removed one by one. For initial burying we need to press foot pedal to third position. And then to pull it out maintain the foot pedal in second position. Next, let's discuss stop and chop technique. Here we have to make first initial trench. We should make the trench deep enough for the quadrants to separate. And we should be able to see faint red glow from the trench. Then we need to separate the quadrants by using phaco probe in one hand and chopper on other hand. Important point to remember is going to the depth of the trench for separation. And once the separation is done we have to rotate the nucleus to 90 degrees. And then we will have to engage the nucleus by giving some bursts of energy. Phaco probe is buried sufficiently, then chopper is used to do horizontal chopping from the peripheral edge of the nucleus. Once both quadrants are divided into smaller pieces. Each piece is removed one by one with minimal bursts of energy for holding the nucleus. And pulling the nucleus in aspiration mode. Let's now proceed further into direct chop technique. Here we are using vertical chopping technique. First we will engage at the center of nucleus by giving some bursts of energy, so that the phaco probe is buried sufficiently, Then chopper is used to do vertical chopping from the mid-periphery of nucleus. Then once the nucleus is separated into two quadrants, we have to rotate the nucleus. Then one needs to divide them further into smaller pieces. Each smaller quadrant is removed one by one with minimal bursts of energy for holding the nucleus and pulling the nucleus in aspiration mode. Next comes cortex aspiration. Here in this model we are using coaxial IA probe for cortex aspiration. We need to catch hold of anterior fibers and sweep it in horizontal plane. This sweeping helps in reducing zonular stress. And we can catch and remove bigger chunks of cortex. It helps us to remove cortex faster and reduce the surgical time. For IOL implantation, initially we need to introduce the lens straight till the leading haptic reaches the rhexis rim. Then we need to lift the trailing haptic such that IOL enters the bag. And then we need to slightly retract and press the haptic optic junction to introduce the trailing haptic inside. With these simple maneuvers, lens can be implanted in the bag. Let's conclude the story. After finishing her training, she was very happy and sent me a thank you note. This gratitude is what any teacher craves for. With this we will conclude our video. Just one message to everyone. If you have got a problem, the perfect solution could be 3D printed. Thank you. All the models displayed in the videos are designed by us. And we have uploaded all the design file on NIH 3D website. Anyone can download it for free by scanning the QR code.